going on, students? How you doing today? It's either Wednesday night and you're preparing for your test, in which case don't watch this video unless you're prepped for your test. But if you are prepped for the test, you should go ahead and watch this video. If you just took the test, hello, I hope you did well on your test. The next chapter we're going to be doing is, hey, remember way back at the beginning of the year, like in chapters 1 and 4, I think, we did some we first did some arithmetic sequences, and then we did some geometric sequences. Well, that's what we're going to spend the next week doing, next week and a half. Another small chapter, chapter 9, and it's sequence and series. And before we can get into series, which we're going to get into tomorrow, today we're going to deal with sequence. And a sequence is it's just a set of numbers. Now, the set of numbers are usually mathematically related to each other, but they don't necessarily have to be. So, here's our first one. And I just want you to know right now, I think this is a really poorly written question. And I'll say why in 5 seconds. It says write the first 5 terms, and it gives me an equation. So I need to plug in I need to plug 5 numbers into this equation and have it come out. But they're not telling us where to start. You normally, on a problem like this, they give you a starting point. And typically, you either start at 0 or you start at 1. But in this problem, they're not telling us. So how do you know which number to plug in first? And the simple truth is when you look at this, you don't know. But I've looked at the answer key, and the answer key always started with 1. So it should include like n greater than or equal to 1 to let you know that 1 is the first number that you plug in. So I'm going to do that. U1, that'll be 6 times 3 to the 1 minus 1. And let's see, 1 minus 1, that's 0. 3 to the 0, that's 1. And 6 times 1, it's 6. All right, that's U1. Then U2, you plug 2 into the mix. So 6 times 3 to the 2 minus 1. 2 minus 1, that's 1. 3 to the 1, that's 3. 6 times 3, 18. U3, 6 times 3 to the 3 minus 1. 3 minus 1, that's 2. 3 squared, that's 9. 6 times 9, 54. Do you have to do all this work? No. Look for a pattern. What are we doing to get from number to number to number? Well, it sure looks like we keep multiplying by 3. And if you keep that pattern, 54 times 3 is 162, I think. I'm going to double check that. Yeah, it is. And then if I multiply that 162 times 3, oops, I did 162 times 162. 162 times 3 is 486. So the first 5 numbers, you shouldn't list it like that. You should make a list. So 6, 18, 54, 162, and 486. The first 5 terms, assuming that n equals 1 is the first number to plug in. Are there different ways of doing this? Of course there are. We've done this chapter. Remember when we were graphing exponential equations? And in exponential equations, you are multiplying by 3. So once you have that first term, 6, because you have this 3 to the n minus 1, that tells you that you're going to be multiplying by 3 to get from number to number to number. So right after 6, you could have just started, ignored all this work, and then just taken that 6, multiplied it by 3 to get 18, by 3 to get 54, and so on. More than one way of doing this. This work here isn't necessary, but if that work helps you get the answer right, you should include that work. All right, those are forward problems where they give you an equation and they give you an equation and you build the sequence. This is then we have backwards problems where they give us an explicit formula, or no, they give us a sequence and we need to write an explicit formula. This one, we're subtracting 3 to get from number to number to number, which means this is an arithmetic series, or sequence, excuse me, which means slope. And because we're subtracting by 3 every time, I'd go -3 to the, because I was treating this like n greater than or equal to 1, I'm also going to treat this 24 like it's the first term. So n minus 1 plus 24. I was just using, this is point slope form, that I have a point 1 comma 24, so 1, 24 with a slope of -3. So I was using un equals m, the slope, times n minus this first point, so I guess it's just 1, and then plus what that, I'm not sure what I'm writing here. Typical point slope form is a y equals thing, so it's y equals m times x minus the first x point, so x1 plus y1, the first y coordinate. So this was me turning point slope form into a sequence looking equation. Now, like I mentioned, your series isn't complete if you don't have a start point, because if you gave this to somebody, do they know whether to plug 1 in first, or should they be plugging in 0 first? So you should mention n is greater than or equal to 1. And I'm thinking, did they do that on the answer key? Oh, they didn't do it on the answer key. Elliot needs to update the answer key, and he will. All right, that's number 1. Number 2. I notice 24, 12, 6, 3. Every single time we're going by half. It's dividing by 2. But if you're going to use this geometric sequence formula from what we did way back, I think in chapter 4, you don't want to think division, you want to think multiplying. And dividing by 2 is the exact same thing as multiplying by the reciprocal, so multiplying by 1/2. 24 times 1/2 is 12. 12 times 1/2 is 6 to 3. If you recall, this geometric way back when we were doing, I think it was chapter 4. No, it was chapter 5. The first chapter, 5a, was exponential equations, and we worked these equations like this, that that y was equal to, this is our first y coordinate, so y1 times then your multiplier, I think we did b to the x, y equals b to the x, yeah, to the x minus x1. Is our typical equation. Okay, so getting this plugged in, it's a sequence, so I need to use un. That first term is 24 times my b, my multiplier, that's 1/2, to the, I'm not using an x here, I'm actually using a variable of n, so n minus, this 24 represents the first term, so n minus 1. And then same thing, you're going to start with 0, you're going to start with 1. We're setting these problems up to start at n greater than or equal to 1 because we're using n minus 1. If we wanted this to be the 0 term, it would just be to the n, but then it would need to be n greater than or equal to 0. So once again, I guess you could view this equation like this, or you could also view it as un equals 24 times 1/2 to the n, but instead of plugging in 1 first, you'd plug in 0 first, so n greater than or equal to 0. Either answer, 100% acceptable. I guess you could also do the same thing here, is instead of going n greater than or equal to 1 and using n minus 1, you could have said -3n plus 24, comma, n greater than or equal to 0. Both equations work. My answer key, though, I'm going to have the answer key reflect these ones. All right, I can get this lecture done in under 10 minutes if I can just finish up in under 5. There's Big Head Elliott. Have a great day, everybody. Go Blue!